So I wanted to review a few things about the exponential function e to the x. So as we've seen before, the domain of this function is all the real numbers. The range are the values from 0 to infinity, not including 0, so the positive values, positive real numbers. This function has an inverse function, and it is a logarithm function. And so if we take the function g of x, recall that if f is 3 to the x, then its inverse function, which I'll call g in this case, would be log base 3. This just tells you which exponential function this logarithm is associated with. That's all it is. This is simply an identifier that lets you know that this logarithm function, log base 3 of x, this function is associated with this exponential function. It's a label more than anything else. It's not a computational thing. There are some computations you can do with it, but essentially it's just a labeling to let you know which exponential function this logarithm is associated with. Similarly, if we had 1/2 to the x, remember, any value that's bigger than 0 and not 1 is allowed. So if for some reason you wanted to use 1/2 to the x, then its inverse function would be a logarithm, and the subscript would tell you which exponential function it's associated with. Again, essentially, in this regard, it's simply a label. We would say log base 1/2. So these are inverse functions. Well, what we have is e to the x. Remember, e is a number. It's approximately 2.7. It's 2.7182, blah, blah, blah. It's rather like pi. This 2.7182. This number extends on without ending. It is approximately 2.7. It is a number which is bigger than 0 and not 1. So it is a valid use for this base. So e to the x, well, what then would be its associated logarithm function? We would use log base e. So all this says is that this function is the associated logarithm inverse function of this function, e to the x, using this base. Now, this is used so much. In fact, in your experience in the calculus, it's almost hard to imagine you using any logarithm other than this. You would have to craft problems specifically designed to create these. And really, in the calculus, we're going to talk about it even later this semester, there's a tool you can use, a procedure you can use. If you're given a logarithm other than this, there's a tool you can use, a procedure you can go through and change it into this, and then do everything only with this function. These two functions have very special properties that are extremely important in the calculus. And no other functions have them. These have similar, but they're not nearly as straightforward, not nearly as easy, not nearly as smooth. And so anytime you have any other logarithm, typically the first thing you do is you translate it into this log base e. This is used so frequently that this abbreviation takes too long to write. What happens is we abbreviate this abbreviation. And so even though this is correct, no one ever writes this except to introduce this idea. There is an abbreviation for this abbreviation. We write this as ln. This is the natural log. Let me write my argument better. This is the natural log. So on your calculator where you see ln, that stands for the natural logarithm. It's NL. It's not NL, it's LN, because this was originally done in Latin, and as in the Romance languages, Spanish and French, the adjective follows the noun. So it's logarithm natural, but it's the natural logarithm. And anyone who knows what you're talking about knows ln means log base e. These are inverse functions. E to the x and natural log are inverse functions. And every property that pairs of inverse functions possess, these two functions possess in relation to each other. So, among other things, what are some properties that we know? So I'm going to rewrite all this. Well, we know that if we take log base b of x and take b and raise it to that power, so if you apply logarithm and exponential in sequence, it is as if they cancel and you're left with just that value. Now, how does that manifest itself in this particular expression? Well, because this is more concise, there's a more concise way to write this. The way that would appear here is this. In this language, or in this base expression, you would say, if you have the natural log of, and I'll be more general than x, I'll say the extremely unofficial term stuff, natural log of some stuff. If you take e and raise it to the power of natural log of something, then it is as if those cancel. In fact, this is a property we will use. It is as if those cancel. They are inverse functions, and what you're left with is just the argument. E raised to the natural log of something is the something. In fact, let's write that as a property. E raised to the natural log of something is the something. Now, to make this look a little more official, the way you would typically write this to make it a little more official is this, e to the natural log of u. For whatever reason, the variable u is used in textbooks to represent a generic expression. It has to do with some things you'll encounter in calculus. So e to the natural log of u, e to the natural log of the stuff, is the stuff. Now, the second property is the same thing in the other sequence. We know that for any base, if I have b raised to some power, and then take log base b of that, well, log and exponential cancel. Log and exponential cancel, and you're left with just the argument. Well, that's true here. Similarly, if we have e raised to the power of some stuff, but then take the natural log of that, natural log and exponential applied in sequence. See how they're applied in sequence here? They're applied in sequence here. So natural log and exponential, it is as if they cancel. They're inverse functions. And what we're left with in this case is this very appropriately designated stuff. More officially, we would write this, the textbook will write this format, and the textbook would write it like this. If we take the natural log of e raised to the u, where u may be any expression that's defined, for which this is defined, then this is the natural log and the exponential cancel, this is the u. So this might be a nice convenient way to think of it, but this is the way you tend to write that. E to the natural log of stuff is stuff, and natural log of e to the u is u. All right? So, now we have some other properties of logarithms we're going to talk about, and that will be, we'll throw that into our next video. But these are the two big properties. First, e to the x and ln of x, natural log of x. These are the inverse functions. Before I leave, maybe we should draw the graphs of these. The graph of e to the x, roughly speaking, looks like this. The graph of natural log is the reflection across that line that a graph of natural log looks roughly like that. So the graph of the natural log function is this. We have the domain. The domain, well, the only part of the x-axis we're using are the positive values. So the domain is from 0 to infinity. But the range, we are using the entire y-axis. The range is all the real numbers. Either this version, or if you prefer the double stroke R, all the real numbers. That corresponds to the fact that its inverse function, e to the x, we've seen, the domain of e to the x is all the real numbers, and the range is the y-axis. We're only using the positive values, so the range consists of these values from 0 to infinity. And again, notice what happens with inverse functions. What was x becomes y, what was y becomes x. This is asymptotic to the x-axis negative, this is asymptotic to the y-axis negative. This passes through the point 0, 1. This passes through the point 1, 0. And so all these properties are inherited because these are inverse functions. So we have the function e to the x and the function natural log of x. And then we have these two basic properties. These are the big star properties that when you apply exponential function and natural log in sequence, and which one's first or second is irrelevant, e to the natural log of a quantity is the quantity, the natural log of e to the quantity is that same quantity. And so those are the properties of the exponential function and the natural log function.